Good day and welcome to lesson 2.6 Properties of Quadrilaterals. So here we've got some special types of quadrilaterals and their properties listed below. Just because of the nature of this summer school course and how compressed it is, we're really only going to focus on a parallelogram, rectangle, and a square. So, classifying quadrilaterals. We often classify quadrilaterals using slopes, midpoints, or lengths. A quadrilateral is any four sided polygon, and they can be convex, so no angle is greater than 180 degrees. Special types of quadrilaterals will have unique properties, and we're going to, as I said, look at three. The first one is a parallelogram. And a parallelogram we've already come across in this course, but it has two pairs of parallel sides. The top and bottom are parallel, and the two sides are parallel. And the opposite lengths are also equal. So, an example of a parallelogram right here, we can see it's not your traditional rectangle. Uh, the lines on the opposite lines are both parallel to one another, and they're the same length as well. And they often look like they're on a bit of a diagonal. They look like they're about to collapse. And that's how you can tell a parallelogram. So that's one of the ones, one of the quadrilaterals we'll focus on with our question. Number two is a rectangle. And a rectangle is a parallelogram that contains four 90-degree angles. And when we talk about a rectangle, the formal definition does include a square, but for our purposes, we're going to make a square a separate case. So a rectangle not only is a parallelogram that contains four 90-degree angles, but um, like this one here, uh, our opposite sides are going to be the same length, and the sides and the top and bottom are going to be different lengths. If they're all four sides are the same length, then you have a square. So a square is a parallelogram that contains four 90-degree angles, and all four side lengths are equal. So we can use the knowledge that we have to this point in order to figure out what type of quadrilateral we're dealing with. So classifying quadrilaterals. Example 1, we want to verify that the quadrilateral ABCD with vertices at 4 or sorry, A negative 1 4, B 6 1, C 3 negative 6, and D negative 4 negative 3 is a square. So really what we're going to be doing here is for this question we'll determine the lengths of the four sides. If the sides are all the same length, then it's a square. And we can use Desmos as well to give us a general idea. So let me just flip over to Desmos quickly. Here we go at Desmos. I put in my coordinate points of negative 1, 4, 6, 1, 3, negative 6, and negative 4, negative 3. So we can see it kind of looks like a square, but we're not 100% sure if it is or not. We could also just draw lines and match up our corners. Hopefully, you've got a ruler when you do this. I do not at the moment. So mine's going to look a little rough, but you get the general idea. So this is looking like a square. And if it is a square, then all four sides are going to be equal lengths. All right. So if all four squares are going to be equal lengths, then what we're going to have to do is find the length of each of these line segments. There is some good news here. We don't have to find the length of four line segments. We only have to find the length of three line segments. Because if this length, and this length are all the same, then the fourth length has to be the same. So let's just go back and we'll do some lengths of line segments here to figure this out. So first we're going to start off with the length of AB. Remember, the formula for length of a line segment is the square root of x2 minus x1 squared plus y2 minus y1 squared. So here we go. We'll put in our x coordinates. 6 minus minus 1. We're going to square that. Plus, do the same thing for our y's. 1 minus 4 squared. So 6 minus minus 1 is positive 7. And when we square that, we're going to get 49. In our y's, we've got 1 minus 4 squared. So that's going to be minus 3 squared. Remember, when you square a negative number, it will become positive. It's the same thing as negative 3 times negative 3. So it'll be positive 9. So we now know the length of AB is equal to the square root of 49 plus 9. So 49 plus 9 is going to give us 58. When we find the square root of 58, it'll be 7.6. So the length of AB is 7.6 units. We'll do the same thing for coordinate points BC and then CD. So for BC, we're going to put in our coordinate points into our length of a line segment formula. So length of BC is equal to the square root of 3 minus 6, that's going to be squared, plus minus 6 minus 1 squared. So 3 minus 6 is going to give us minus 3. Minus 3 squared is going to be positive 9. Minus 6 minus 1 is minus 7 squared. It's going to give us positive 49. And you may recognize those numbers, 9 plus 49. We had that for the length of AB. So we now add those together to take the square root. We already know the length of BC is going to be the same as AB. It's going to be 7.6 units long. Let's do this one more time for the line segment CD. And if that's 7.6 units, we know we've got a square because that'll mean that AD also has to be 7.6 units in length. So the length of CD, once again, we'll use our coordinate points, x2 minus x1, so minus 4 minus 3, and that's going to be squared, plus y2 minus y1 squared, so minus 3 minus 6 squared. So this will become minus 4 minus 3 is minus 7 squared, 49, plus minus 3 minus 6, so that becomes a positive 6. So minus 3 plus 6 is going to be positive 3. Positive 3 squared is going to give us 9. And you guessed it, we're going to have the same two numbers here. So the length of CD is equal to the square root of 49 plus 9, or 58. When we take that square root, we'll find out that it is the same length as AB and BC. So the length of CD is 7.6 units. Since the three sides we've looked at are all equal lengths, line AD must also be the same length because it has to connect those 2 points. So it can't be anything but 7.6 units long. And so for that purposes, we know that the quadrilateral we are looking at is indeed a square. Tune in for video number 2 from lesson 2.6 to look at the next sample question.